So what I ended up going with my project was a concrete truck and the chute, and what angle does the chute need to be at for in order to maximize the distance the concrete can be poured. So as you can see here on my pre-drawn drawing that I made, the chute with all the add-ons is 19 feet, and the height of the chute from the ground, approximately in every concrete truck, it's 7 foot. So with that being said, I would calculate the angle and the distance and how far the chute will be able to shoot the concrete at what angle would it maximize the concrete length. So I did that by finding this side, which was I found it using my Pythagorean theorem, which was c squared equals a squared plus b squared, which in this case was 19 squared is equal to a, which in this case my a would be this side. This would be my a, and this is my c. This would be my b side, and according to my angles as well, this would be my c. This would be a, and this would be b. Okay, so with that being said, my a, well, that's what I'm trying to find out, so I'll leave that as a squared plus b squared, which was 7, so 7 squared. So that came out to be, so now you move over the a squared because you're trying to find that, is equal to 19 squared minus 7 squared, which in that case it would be a is equal to a squared is 361 minus 49. A squared is equal to 312. So that would be a, to get a by itself, you would square root 312, which would give you a being equal to 17.66. If you convert that to inches, it'll be 17 feet, 8 inches. So that's how I found that. That's how I found that side, which was 17, 8 inches. So in order for me now to find the angle, which what I was trying to find a, so a, I would use my cosine, sine functions. So sine is equal to opposite over hypotenuse. So I did a is equal to 17.66 over 19, which was my opposite, which was this one right here. But I converted it to decimals back, and 19 was my hypotenuse. So a is equal to 0.9295. And what I did to get the angle is I do the inverse. So you do sine inverse of 0.9295, and that gave me that. I did that in my calculator, and it was 68.35. So I rounded that down to 68 degrees. So this angle right here would be 68 degrees. So now, and this one will be 90 degrees. So what I did to find B, I can do add all my angles and subtract it by 180, which are the total of the angles. So you can do that, or you can also use the cosine function, which is totally up to you. We can try to use the cosine function, so it would be b equal to cos, which is adjacent over hypotenuse. And so you do b is equal to 17.66 over 19. B is equal to 9295.9295. And now you do the inverse. So you do b equal to cos, inverse cos of 9295, and it will give you 21.64. So I round that up to 22 degrees. And you can double check your work by subtracting or adding them up and make sure they add up to 180. So you can do 68 degrees plus 90 degrees plus 22 degrees, and it should give you 180. Make sure that you're right. So what I found out through this project is that the angle that you need to have to shoot at would be 68 degrees in order to maximize the distance of the shoot. So in this case, you can see I did, you can pour a slab of 20 by 20. In order for you to maximize the length of the concrete being poured, you will need to have your shoot at 68 degrees. 68 degrees, and it will shoot the concrete at 17 feet 8 inches.